Let's build your first AI agents using Python. In this video, you're going to learn how to build a working AI agent from scratch. Everything that you learn in this video is going to apply to building any kind of AI agent, so don't worry if the demo doesn't exactly apply to a use case that you're familiar with. For this video, we are going to be using the OpenAI Agents SDK, which is a really useful framework if you want to get started with agents quickly. There are other frameworks out there that you can use, just I generally prefer this framework because it has lots of flexibility where I need it and is also very uniformed where I don't need that flexibility. You can see here that the Agents SDK has a few primary features. Agents, which are LLMs equipped with instructions and tools. Handoffs, which allow agents to delegate to other agents for specific tasks. Guardrails, which enable validation of agent inputs and outputs. And sessions, which automatically maintain conversation history across agent runs. Because of the nature of the agent that we're building today, we're only going to be focusing on the agents and on the guardrails section of this SDK. If you are interested in taking a further look at the documentation, you can find the link right here. Here's a quick demo of the project that we're going to be building today. Now, if you're not interested in this specific use case, do not worry because the things that you're learning in this video, like I said, are going to apply to building any kind of agent. This is just a use case that I needed this week, so I wanted to build this tool to kind of kill two birds with one stone. This is the interior design agent, and its job is to generate interior design images based on a floor plan and a design styling that you've specified. So essentially this tool imagines what the interior of the home might look like for you. So I'm just going to chuck in my floor plan there, my example floor plan, and then let's go for a Tudor period design styling as well. I'm going to click Run Agent. This is going to run and I will come back when it's finished running. So the agent has finished running and we have our results here. What it's done is generated some images that it thinks would apply to the floor plan that we have submitted. It looks pretty cool, so let's figure out how we can build it. Before we start coding, here's a quick diagram of the project so that you can see how it works at the surface level. At the start here, we have our trigger, which is a photo input and a text input. The photo input is an image of the floor plan, and the text input is the design style that we have gone for. Next, we have the guardrails, and this is going to be an input guardrail, which is going to check that the image that we are submitting is actually a floor plan. The purpose of a guardrail here is to protect your agent. Now, this could be protecting it from malicious data, or in this case here, protecting it from people submitting an image that is not actually going to work for the use case of the agent. Next, we have the agent, which is going to be the brain of the operation, and this is going to use the image generation tool and a save characteristics to database tool to essentially execute the action that we want it to do. So this is going to do all the thinking, take the design style and the image of the floor plan, and then it's going to use these two tools to get to the output, which is a confirmation of the task or response to the query. In our case, it's going to be some images of the interior of the home and also having it saved to the database. So now let's jump straight into Python. Inside of our new Python project now, we're going to set up a quick environment. And we're also going to install some dependencies that we're going to be using for this project. So for this, we're going to be using the OpenAI Agents SDK. We're also going to import OpenAI, Pydantic, which is going to allow us to create data models, Async.io, which is going to allow us to run our code asynchronously, and also Streamlit, which is what I use to build my front ends for my project. So this isn't necessarily needed, but it's quite a useful tool if you do want to build front-end demos for Python projects without having to build HTML, CSS, and create a backend and stuff like that. Let's just install those. Inside of the lib folder, we're going to have a few files. We're going to have the agent file, which is going to house our agent logic. We're going to have the tools file, which is going to house our single tool that we're going to use to save the interior design to the database. And we're also going to have a files folder, which is going to house any of the admin for receiving and also storing files in our local computer. We're also going to have a main.py, which is going to be used to actually start our agent, and that's all it's going to be used for. So when we run this Python project, we're going to asynchronously run the main function, which is going to contain our agent logic. This is just housekeeping, I guess, for this project. So here we essentially just want to be able to do result equals await run agent, and then that's it, sorted. So now we can build that run agent function. Inside of our agent folder, we are going to import the agents library and import agent and runner for now. So now let's just create a basic agent so that you understand how it works. Let's call it my agent. And it's going to have a name my call agent, instructions. So very quickly, we've created a basic agent. It's called my call agent, and its instructions are to answer the mass questions that the user submits. To run this agent, all we need to do is create a new function called run agent, and then create a result, runner, use the run function, pass my agent, and then whatever question the user wants to submit. For example, what is 2 plus 2? We're then going to print the result and also return the result. Inside of our main file, we can import this. Import run agent. And then there we go. So now let's run this agent for the first time. We've run into an issue. We do not have our OpenAI API key set. So if you didn't know, OpenAI service is a third-party service, which means that we are going to be connecting to the internet in order to be able to send these requests to their servers. For that, we need an API key. So if you don't have an OpenAI API key, you'll need to set one up, and you can do that by going to your OpenAI platform dashboard. Inside of your project, you can create an API key, and we're just going to call this local key, for example. Once we have the API key, we can then paste it into the OpenAI API key environment variable inside of a .env file. You never want to store your environment variables inside of your code, because if you publish your code anywhere, then your environment variables are going to be exposed, and that is going to create a security risk. Now we need to make sure that these environment variables are imported. So we're going to do load.env here. And now automatically the Agents SDK is going to get the environment variable from the .env file and import it into the project and use it for the agent. So we don't need to do anything else. Run this project. So you can see that the print that we have asked it to do is printed out a final output as well as a few items. So say, for example, if it wanted to provide you different options, it could do that, but this is quite a simple task. So it's only providing one output, the final output, which is 2 plus 2 equals 4. So it solved the mass problem. And we can change our input here to be, for example, what is 2 minus 2? Two minus 2 equals 0. So we have created an AI agent that solves mass problems. This is a really simple use case, which doesn't really require an agent to be able to solve these problems, but it has demoed the structure of creating an agentic functionality within your project. You can then fill these agents out with things like tools, or you can select, for example, the model that you want to use. Anyway, let's focus on building the interior design agent. I'm just going to swap some information. So you are the interior design agent, and our prompt is going to be here. Now for this agent, we do need to give it a prompt that is going to give it enough information that it needs to be able to execute the task that we want it to execute. This is the prompt that I've come up with, and I can walk you through it now. You are an interior design agent that can generate design images for every room in a home based on the floor plan that is submitted by the user. You should approach the problem using this process. 1. Identify the rooms in the floor plan image submitted by the user. 2. Identify the realistic dimensions of each of the rooms in the floor plan. 3. Plan the layout and design elements for each room based on the user's preferences. Take into account the placement of fixed features such as doors and windows which are visible in the floor plan. Generate one image for each room based on the design plan, and save the interior design details to a database for each room that you have generated. Only save the details of the design after you have generated the image. Save the interior for this entire floor plan in a single database entry. Do not make multiple database entries. You do have to specify things very obviously to these agents, otherwise they will assume that they are allowed to do certain things that you perhaps don't want them to do. The user's design preferences will be submitted using the user prompt. Then I've added in some image generation guidelines for it as well. Ensure that the images are relevant to the floor plan. Ensure that the images are from a camera perspective that showcases the entire room. Do not add in windows or doors where they do not exist in the floor plan. Do not generate individual images of hallways, as these are not required. And only generate a maximum of 5 images in total. I've just added that in there because I don't want the agent to generate loads and loads of images and essentially take too long while we're testing. And output, you should return the final output of the agent, including the generated images. Do not output text links to the images in the final output. This is a really useful prompt. Now, say for example that we wanted to run this. We could run it with a futuristic home prompt and it would try to generate an image. However, it doesn't have an image generation tool and it also doesn't know what the floor plan looks like for the home that we want it to generate the designs for. So there's two problems we need to solve. We need to give it an image and we also need to get it to generate images. First, let's focus on the input side of things. For our input, we're going to add a design style parameter, which is going to be a string, and also a floor plan image, which is going to be a string path to the image on our local computer. I'm actually going to create a new folder here called resources where we're going to put that image for now. This is where our files folder comes in. Now, I'm not going to spend too much time here. I'm just going to paste the code in that I've already written because I want to focus on the agentic functionalities of the project. So here we have two functions. First, we have open file. Now, this is going to open a file after the agent has generated it, so don't worry about this for now. But we're going to use this function, to receive the image from the resources, to retrieve the image from the resources, So we can essentially just pass in the name in here and it would automatically get it from the resources. Let's actually upload a quick floor plan to the resources here. So we have our floor plan image, and now inside of main we can pass these two examples. Inside of our main function, I'm passing the two parameters, which are the design style that we want to go for and also the location of the image inside of the resources folder right here. We can then use this function here to retrieve the actual image file. And we need to make sure it's imported as well. There we go. And then we can pass this image to the agent. Now we can't just pass it into the text prompt here, so we need to create our own user input. I'll do that now and then I'll walk you through how it actually works. So our run agent function has a formatted input. This is going to be a JSON array, which is going to receive a bunch of messages to send to the agent. So for example here with the role, you could set this to a system prompt, and this would be, imagine you have a conversation and you would essentially be sending the system prompt, which is say anything that the agent has previously said, and then the user prompt, which is anything that the user has said. So for example, here we could define another system prompt to give the conversation history, to add history to the conversation if we wanted to. So this input contains a single message, which is going to have two items in its content array. It's going to have the input image as a base64 string, and it's also going to have the design style as input text. If we were to run this now, the agent would receive the image and it will receive the design style and start thinking about what rooms are in the floor plan and also how it can generate those images. But it can't actually generate those images yet because it doesn't have a tool that allows it to do so. It's got no tools there. So let's see how we can generate images using a tool. If we go to the OpenAI Agents SDK website here and we click on tools, you can see that the Agents SDK comes with a bunch of preloaded tools already, things like the web search tool, the file search tool, the computer use tool, and down here we have the image generation tool. This essentially allows us to use image generation models created by OpenAI directly in our Agents SDK project, which means that we don't have to go and make external API requests to another image generation model. You could quite easily do that though, and if you wanted to, I am going to be showing you how to create a custom tool later on in the video, so you could quite easily adapt that code for an image generation model. Back in our code now, we're just going to import the image generation tool, and then we can pass it into here. Now the image generation tool needs a few parameters. It needs type, which is image generation. That's the only option it has for type, so I don't know why it's actually required. It also needs an output format. We're going to output some PNGs. It needs a quality. I'm going to select low quality for this, although in the demo that you saw at the start of the video, it was for high. Just it's a little bit quicker while we're testing things. And also it needs size, which is 1024 by 1024. That does all need to be in an object. I have just noticed that's the reason why it's not working. There we go. So this is your full image generation tool configuration. We've got this working agent now, but the problem is that if we run it and print the results, we aren't going to see those images. We're just going to see a description of what those images are because we asked it to return a final output here. So we need to find a way of seeing those images. And to do that, we are going to use the OpenFile function, which I created earlier, and essentially loop through the items that the agent has returned to then use the OpenFile function to open each one of those images. So I'm going to write that code now, and then I'm going to show you how it works. So I've created this for loop, which is going to loop through the new items that are returned by the agent. If the item is a tool call item, specifically an image generation call tool item, and it is an image, it is going to save the image to the output folder, which we need to create. And then it is going to also append the image path to the image paths array. So say, for example, if we wanted to show these images on the front end like I did in the demo, then that's how you would do that, because you just say, show all of these images that are in this array in a loop. For now, I'm just going to use the OpenFile function to open the outputted file in the same directory. And make sure that you import the OpenFile function here and also the base64 package that's being used to read that image data and write it as well. With this code written and making sure that we have created the output directory here, we are going to run it. I will be back when it is loaded. Okay, so now the agent has finished processing. It has created some images in the output folder here, but it hasn't opened the files, which is a little bit odd, and I wonder why, but I'm not going to worry about it yet. So here we can see a few of the example images that it has generated based on the floor plan. So it's generated the living room, it's generated the kitchen, as well as the office, which I have checked. There is an office there. It's also generated the bathroom and the garage as well. This effectively is an interior design agent, but there are a few things that are missing that would stop us from, one, achieving the brief guidelines that we set out, but also deploying this to production. So here are the two things that are missing. One, we don't have a custom tool that is going to save the information on the designs to the database like we specified at the start of the video. And we also don't have any guardrails. So for example, this floor plan image could be an image of a donut, and the agent would still be trying to create images based on the image of the donut, which you have said is a floor plan. So it won't end well, and you'll end up spending loads of money on credits for image generation and processing power for the agent when it's not going to give you an actual valid result. So what you do need to implement is guardrails. We're going to do that first, and then we'll focus on creating the custom tool. Let's just go to the guardrails documentation here. So there are two kinds of guardrails. Input guardrails, which run on the initial user input, and output guardrails, which run on the final agent output. So you can essentially, inside of our code, let me just go back to it, you can essentially provide this agent here with some guardrails. Input guardrails as an array, and output guardrails. And it would essentially, if you're using an input guardrail, would pass all of the inputs that you've submitted through another agent that you have created before sending it here. Same with the output. It would pass the output of the agent through another agent to make sure that, say, for example, the agent isn't swearing in the response. Because if you're creating a customer service agent, you want to make sure that your agent isn't going to send swear words back to your customer. You could create a guardrail agent for that to detect swear words. But for now, we're only going to focus on input guardrails, and this is going to be another agent which is going to check that the floor plan image is a floor plan. There are a few steps that we need to take to create this guardrail. So first, we need to create an example data object of the output of this agent, of this guardrail agent, sorry. So we'll just call that the guardrail agent output, and it's going to be a base model. We're going to be using Pydantic, which we installed earlier. So from Pydantic, import base model. And here we're going to add a Boolean, which is going to be is not allowed. So the guardrail agent is going to output is not allowed. And if it's not allowed, then the guardrail agent has effectively been triggered. It's going to catch that trigger and not run our interior design agent. So now we can create the agent. It's going to be a guardrail agent. Other than that, it just seems like a normal agent, to be honest. Floor plan checker agent. And then for our instructions, I have them already pre-written. Check if the image that the user has submitted is a valid floor plan and that the user's design preference input is actually relevant to the interior design. The user must not ask for anything offensive or not safe for work. Little typo there. We aren't going to define any tools, so you could not provide it or you could just leave it blank like I'm going to. And then our output type is going to be this guardrail agent output. Now, the really cool thing about Pydantic with agents is that you could set out a defined structure for the data that you want the agent to output. So say, for example, if I wanted this interior design agent to output the parameters of a interior design in a structured manner, I could say, for example, have something like this, like class, floor plan, design output with a base model. And then I could say, we could have a rooms array, which is a list that has the number of rooms. We could have maybe the design style. We could have the color palettes, for example. Wow, this is really good. We could also have, say, for example, a list of furniture. And then this would be a structured output that we could then store in a database, or we could, for example, submit as a response back to a front end so that we could have this nice table that says all of the parameters of the design that the agent has come up with. And you could essentially just pass this as an output type here. And this agent will now output JSON. After still generating those images, it would output the JSON data of the design output, which is list of the rooms that it's generated, the design style that you asked for, the color palette. So that's really useful. I'm actually going to leave that in there so that you can see how it works as well. But anyway, back to the guardrail agent. We have passed the output type, which is the guardrail agent output, and it's going to send out one variable, which is going to be is not allowed. So now we need to wrap this agent inside of an input guardrail function just to declare that this is a input guardrail agent and not just a normal agent with this specific output, because realistically, apart from how we've named it as a guardrail agent, it isn't actually a guardrail agent at the moment. It's just a normal agent. So we need to specify that it is in fact a guardrail. We can do this by importing the input guardrail, and also we need a guardrail function output as well to make sure that the output of this function is going to be in the correct format for our interior design agent to receive. So here we have the guardrail function. The input data is being received and it's going to output this guardrail function output. We can now then use result, run the runner with the guardrail agent and the input data, and then we're also going to output the guardrail function output as output info here. Now I'm just going to change that to our final output. What we can do here, which I haven't mentioned yet, is you could add in a reason here so that the guardrail agent can respond back to the user. This is why I have not allowed this input to be processed. So we're going to add in a reason there, pass that there, and then we also need to add in a tripwire triggered. So this is a yes or a no, is the tripwire triggered? You may have thought that it was weird why I added in almost like a double negative here, but this is because if we put is allowed, this value would be true, and then we'd have to reverse it here to trigger the tripwire. So instead I just put is not allowed, and we can then pass that there. So if the input that the guardrail agent has received is not allowed, it's going to trigger the tripwire and then not run our main agent. We can now pass this guardrail agent into here. So now let's test our guardrail function. To do this, we're going to swap this floor plan image out with another image. Let's just call that donut. So now instead we're going to pass a donut, not the floor plan. So we do need to update our code slightly. just make sure that we've saved our guardrail function and that it is passed here. We can go to the main folder and we're going to swap that out for donut. Now, if we run this, it should stop and say, hey, this is a donut. Sorry, donut png.jpg. I do actually, before we do this, I do want to also add in a catch for the error, because it no doubt will throw an error. So inside of our run function up here, I do want to add in, let's add it in here. We're going to add in a try except, or a try catch effectively, and input guardrail triggered. So if the input guardrail is triggered at any point here, which it will be when the agent is running, it's going to stop running any of this code and it's going to throw the error here that we want it to. So input guardrail triggered, and it's going to print that the guardrail was triggered so that we know it was triggered. Let's run it now and also make sure that donuts JPG is being passed and not PNG, as I made that mistake a second ago. Sorry, you need to run it in a context wrapper. So here, see how we only had a few imports for the main agent, and then now that we're running in, now that we're adding in different things, makes it a bit larger. So then we also need to pass the main agent, and we also need to, and this is going to be the input data. I believe we stringified as well. This should be good. My sincerest apologies. So now it's been triggered, and this is because we have submitted a donut and not a floor plan. Let's swap that back to the floor plan image. And now this should properly run, because the guardrail agent is going to check that this is a floor plan image, and it's going to say, yes, it is a floor plan. Let's generate those interior designs. It's taking a little bit longer than it did for the guardrail trigger. So what that means is it's probably passed it already. So now it's finished and it has opened the files this time. I think what happened last time is it did actually open the files, it just opened them on my previous screen, which is a bit embarrassing, but there we go. So this has worked and these look really nice, but it's worked because we did submit the floor plan image and not an image of a donut. When we submitted the image of the donut, the guardrail function ran the guardrail agent and detected that this image was not a floor plan, and therefore we don't want to run this more expensive, more processing power, much longer task just to get an error that says that this isn't a floor plan, or some output that isn't actually going to be useful for us. There's one more thing to do. Let's create a custom tool that our agent can use to save information about the interior design to a database. Custom tools are essentially just Python functions. You can make any Python function and turn it into a tool that an agent can execute. For example, print hello world, or save something to a database, or call a third-party API. Anything that you want to do and that you could do in a normal Python project, you can get an agent to trigger it. For the purpose of this tutorial, I am going to mock the database so that we don't have to spend loads of time setting up a database connection, which isn't really relevant to the video that we're making at the moment. So we're going to start off by creating our Python function, which is going to be save design data to database. Now we can pass data, and it can be whatever format we want. So currently this mock is just going to save the design data to the save database. We are going to just save it to a txt file. So with open txt file, write data. Now, like I said, the data could be any structure that the agent decides that it wants to submit to the tool, because we have just said, as long as it's an object, it's fine. And of course, if you've ever worked with a database, that's not fine. You need to add some structure to it. Fortunately, we have already talked about structure before. We have used Pydantic to create this design output. So let's just modify this to say design database entry. Import Pydantic base model. And then we are going to make the function require a design database entry in that structure. I'm still going to save it as a string. Hopefully that still works, but I'm going to save it as a string within our text file just to make things a little bit easier. But essentially this function now requires data to be in this format. So the agent is going to submit data in this format. And this kind of feature is essential really if you want to connect third-party tools. So say, for example, if you were having your agent call an API to maybe create an invoice via Stripe or something, you need to make sure that it's going to generate the right data in the right format to send to that API. Otherwise, it's not going to work and then it's not really agentic. Anyway, there's one more thing that we do need to do before we pass this function to the agent. We need to add in the function tool right here and just pass that from the OpenAI Agents SDK. So import a function tool. So now that we've got those imported, this is now a OpenAI agent tool and not just a boring Python function. We can go up to here and just import it. So from lib tools, save design data and pass it into the tools array here. Now I do want to make sure that this agent definitely saves it. So we are going to do that as well. Just going to add in, you must use the tool save design database to do this. I just want to make sure that this functionality works for this demo. In most cases, you won't need to add this, but on the off chance that the agent decides, well, actually, I don't need to save it this time, this is going to help with that. Let's also remove our print result and print output item here. I am going to, inside of the function here, print design data saved, but we should also see it added to the output here as well. And I'm also going to change the design styling as well. We're going to call it 1920s Art Deco so that you can see a different style and we know that the agent has actually generated those images again. Let's run it. So now the agent has finished, and as we can see here, it has added the design output file to the output folder. It's also generated some very nice 1920s Art Deco images, although I'm not sure what that is right there. But it has also generated this design output.txt as a mock for a database entry. Here you can see that they have added in, or it has added in the living room, the kitchen dining room, the office, the store, the toilet. It's added some information about the design style prompt, as well as the color palette and also some furniture. So realistically, I could go to my furniture shop and be like, boom, I want this. And these are all the individual elements that it has included in these designs. Now, I have noticed here that it has called the save database function multiple times, which realistically means that if we weren't just replacing whatever was in this file, it would have added multiple database entries. So there's potentially some tweaking that we need to do to the prompt to make sure that it only calls that function twice. Overall, I'd say that is a very, very useful AI agent. All we have to do is submit a floor plan. We submit our design prompt, our styling prompt, sorry, and we get a bunch of AI generated images of exactly what the house in this floor plan could potentially look like. Granted, there are a few inaccuracies, I think, around like window placement and stuff like that, but that's all in prompting. That's all in refining the prompt to make sure that you get the best output. But realistically, we have still created a very useful agent that takes an input, executes a task, and outputs it, which is the goal of the video. For the demo that you saw at the start of the video, I did create an interface for that, and I did that using Streamlit. So I'm just going to paste that in now and show you what it would look like, but it will be in the GitHub repository that you can download at the end of the video. This is the code for creating that interface. So if I run it now, I run with Streamlit, run app.py. This is if you are interested in this, and you will get this nice interface where you can type in your style preferences and select a file from your computer. So it's a much more user-friendly way of interacting with the agent, but it's not required as part of this tutorial. I've made all of the code from this video public on GitHub, so if you want to check it out, you can click the link in the description. Thank you very much for making it all the way to the end of the video. If you really did enjoy it or you found the video useful, please do leave a like down below, hit the subscribe button if you're new, and tap the bell icon to get notified every time I post a new video. See ya.